My next one is Pokemon. This one I saw and this is like, wow, this is like the dumbest, craziest thing ever. I'm liking this because I see a guy dressed as Spike over here, I see Nurse Joy over there, I'm just like hitting my niches here. So we got this Pokemon called Magcargo, and according to the Sapphire Pokedex, his body temperature is 18,000 degrees Fahrenheit. Yeah, okay, 18,000, that's a big number. I don't do whatever numbers. Let's put that in some context. I majored in astronomy, so I deal with things in Celsius and Kelvin a lot better, so we'll put it there. But what's important here is that 18,000 Fahrenheit, or whatever that is, that's twice the temperature of the surface of the sun. Yeah, the thing about the sun, though, is suns cause sunburn. So how much is it going to suck to be next to a Magcargo? So the sun's giving off ultraviolet radiation, which is what gives you a sunburn. And so I want to know, let's put it in context. You take out a Magcargo 10 meters away, which is about 30 feet. How bad of a sunburn would you get from him as compared to the sun?
Yeah,
so,
you're feeling fine.
So the thing to understand is that light isn't just the colors we see, the red, blue, orange, blah, 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 through violet. There's actual colors on the other side that our eyes just can't perceive. So that's what this graph is showing. We have this visual portion here, and off to the left, past the red, we have what's called the infrared. And then past that, there's the microwave, there's the radio part of the spectrum. And none of that's really too bad. That's not high enough energy to actually cause damage, although people freak out all the time. This is, again, the pseudoscience thing I said in my introduction, that these low energy things are going to give us all brain cancer from cell phones. No, it won't. There's not enough energy to, screw up your DNA, so no. But meanwhile, on the other side here, past the blue and violet is the ultraviolet, and that's the stuff that causes sunburn. Specifically, the ultraviolet B, the ultraviolet A is not as bad, but it's actually good because it causes vitamin D to form. But what we want to know is, how is it going to give off, or how much is there going to be for these two different temperatures? And the other thing that's sketched on this graph here is you see these kind of funny little curves. It tells you how much energy is given off at a certain color or a certain wavelength for a given temperature. But these things that are 3,000 degrees, something like the temperature of a blowtorch, actually gives off most of its energy in the infrared, which is heat. You see a nice blue flame, but realize it's actually giving off more of the energy as heat, which is why it melts stuff, so that's cool. But as you get hotter and hotter, it starts giving off more at the higher energy, so more into the visual, and then if you get hot enough, you can see it'll eventually go off into the ultraviolet. So the sun is actually somewhere up here, like the very top curve, where its temperature is about 6,000 K, and its peak is in the yellow-green. But Magcargo is obviously going to be way worse. So what we're looking at is how much is there under, right here, which is the ultraviolet B, and obviously Magcargo's curve would be way up there. The way we find that out is, and this is where the calculus comes in, is the equation I have in the upper left-hand corner, the upper right-hand corner, that tells you kind of how those curves should form for a given temperature. So you use some calculus on that, integrate over the range of the ultraviolet B, and what you get out of this is that Magcargo gives off 6.44 times 10 to the 23rd watts per meter squared per steradian. Yeah, how many people know what the hell a steradian is? Really? Do you? Good job. No one uses steradians except astronomers, I think. I've never seen it anywhere else. But I'll tell you what those mean in a minute, but just to do the same thing for the sun, it gives off 2.15 times 10 to the 22 watts per meter squared per steradian. So if you look at the digit on the power of 10 there, it's actually really not that far off. Magcargo is giving off about 30 times as much. And that's just on average for the same conditions. So not too bad, that's kind of what we expected. We knew Magcargo was hotter, so we knew he should be giving off more. 30 is not that bad off. But the meter squared and the steradians in there, that's what's important here because there's some other effects. The sun is really, really far away. And that means it's going to take all that light that it's giving off and spread it out a lot. It's like it's trying to spread a little bit of paint over a huge wall. It's not going to be a lot of paint at any one point. But at the same time, Magcargo's this big, and the sun is gigantic. So there's going to be a lot more surface area for the sun to give off that energy. So that's where the meter squared, the surface area, and then the steradians, the distance come into play. So we toss those into what we had before, cancel everything out, and now we have the Magcargo's giving off 3.22 times 10 to the 21 watts. That's how much energy he's hitting you with. And for the sun, now we only have 2.94 times 10 to the 15th. Just looking at the power to 10, that's a difference of 10 to the 6th, which is, what, 1,000,000 times as much? Suddenly 30 doesn't seem so bad. But wait, there's more. We have a nice atmosphere that blocks 98 to 99% of the ultraviolet from the sun. So we need to reduce the suns a little bit. So when we do that now, the sun's only doing 8.82 times 10 to the 13th watts. So yeah, when you divide that out, Magcargo is hitting you with 36 million times as much ultraviolet radiation as the sun. If you're a pasty white guy like me and you burn in 10 minutes, you will burn in a nanosecond. So I think Magcargo is like the most dangerous Pokemon ever. Like, screw Charizard, I think Pokedex says his fire breath can melt rock. Magcargo causes cancer from another continent. So those are my topics from previous years. So now I have 4 new ones. To start off, Samurai 7, which is not a hugely popular anime. How many have seen it? Oh wow, that's actually really good. So just a bit of background, Samurai 7 was a kind of redoing of Seven Samurai, a historical Japanese film done in like the 50s, about some samurai that decide to protect a village for very kind of just selfless reasons, and it's really good. So this part that I'm about to show, it's a fairly long clip and it doesn't have a lot of context, but they're defending the village from the evil bandits that come in and they rig up this kind of cool system to do it. That wasn't the cool part.
This is no life threat. Drop your weapons and cross the bridge one at a time. Fire. Fire!
Yeah, I don't remember what they did with the other one. But so the idea of this is they built a giant crossbow. Crossbows are very powerful, so build it bigger. What's the problem with that? Nothing at all, really. The thing I was interested in wasn't the crossbow part, it was the other thing that they had. It was, they were trying to get some extra power out of it by hooking another rope to the back that was attached to that big cliff thing that they knocked off, and that helped provide some extra force to propel that giant freaking tree. I grabbed some frames, still frames, tried to figure out kind of the size of stuff, and what angle everything was going on at. And so there were people down there that were like this big on the monitor, so I like took them out, glued them together to figure out how big the ramp was. So I figured the tree was like 75 meters tall. It's like a California redwood or something. It's huge. Some of the things that are important here is that if that thing was being accelerated by that rock falling, the rock only falls with the acceleration due to gravity, which is 9.8 meters per second squared, or 32 feet per second squared. If the crossbow part was accelerating the tree faster than the line connected to the rock that's falling would just lose all its tension and go slap. It didn't, so we know the fastest that tree could have accelerated would have to be 9.8 meters per second. Also, the angle of release from that ramp, again, from my little screenshot thing, I figured out was about 1.3 degrees, which is like actually really tiny. That was dumb. So what I want to know is, could they have actually shot that thing that far? So the first thing I want to know is, how fast was it going when it went off the ramp? And this is how many people have taken high school physics? For those of you that haven't, do so. Science is cool. So this is a basic high school physics equation. The final velocity squared is equal to the initial velocity squared plus 2 times the acceleration times the distance over which it accelerated. So I said the ramp was about 75 meters long, or the tree was, and it was at most going 9.8 meters per second squared, so its initial velocity at rest, we can plug all that in, and its final velocity was a cool 38 1/3 meters per second, or about 85 miles an hour. That's not too bad. So, but still, could it reach that far? So next what we need to do is we need to see how long it would have been in the air, and we can do that pretty easily. Another basic physics equation from high school: final velocity equals initial velocity plus the acceleration times the time. We want to know how long it went to go from its initial upwards velocity, so it's a component of the velocity in the y direction, for those of you that would understand that, to the time that it levels out and stops going up or down. So it's at rest in the y direction. So that it would have taken only about 0.08 of a second. So for the time it would go up and then back down to its initial height was less than a second. That's not what the video promised. So how far would it have gone in that time? Well, velocity equals distance times time. Solve for that. It only would have gone about 20 feet. They weren't actually on top of a cliff. The enemies were on the same level. There was just a giant gorge. That's what it was. It initially threw me, and I was like, how tall is the cliff? And then I watched it. Oh, no, it's not. So it would have only been about 20 feet, and its max height would have been about 1.5 feet. So those aren't the best samurai ever. I would not hire them. Next topic.